Hello everyone, welcome to the video. I'm going to be trying to go over how to do one of these limiting reactant problems like we've been seeing in class and doing for homework. So this particular problem is number 5 from the second practice sheet that we did, the which do you need more of number 2, and this is problem number 5. So the problem says, in the reaction above, if you are supplied with 3.2 grams of C2H6 and 1.2 grams of O2, which do you need more of to produce as much water as possible? So let's get right to it. Let's figure out how do we solve this. To solve this, what you're going to do is you're going to look at each reactant individually. You're going to do a little bit of math work, a little bit of dimensional analysis, and then you're going to, after doing that for each reactant individually, you're going to compare their answers, and that's going to tell you what the overall answer to the question is. So let's get started. We're going to start with the first reactant, the C2H6. So I'm told that I have 3.2 grams of it. So that's where I'm going to start. I'm going to begin my dimensional analysis by writing 3.2 grams of C2H6. I'm going to put that over 1. I'm going to change that to moles. In other words, I need to get rid of my units of grams of C2H6. Didn't copy very well, but C2H6, and I'm going to change it to moles of C2H6. Notice how I set that up. That's dimensional analysis. I'm getting rid of my grams of C2H6, so it needs to be on the bottom down there. That relationship is the formula mass of C2H6. So I would pull out my periodic table, I would look up carbon and hydrogen and add it all up, and it turns out that for every 1 mole, it would weigh 30 grams. So that would be changing my grams of C2H6 to moles. But I have to do one more step with the dimensional analysis. I need to do my mole ratio between my water and that chemical. So I'm going to have a mole on the bottom here, a mole on top, and I need to get rid of the C2H6, so that's going to be on the bottom, C2H6, and on top I've got water. That mole ratio is the coefficient ratio. So when I look for my moles of water, I'm looking for the coefficient of 6. For my moles of C2H6, I'm looking for the coefficient in front of C2H6, which is a 2. I can now solve this problem. I can multiply all the numerators, multiply all the denominators, and then divide. And when I do so, I get an answer of 0.32, and the units will be in moles of water. And I know that because my dimensional analysis cancels my grams of C2H6, my moles of C2H6, and I'm left with moles of water. And that's what I've got there. So that's using the C2H6. I then do the exact same thing for the water using its values. So for the water, if I do, or I'm sorry, for the oxygen, which is the other reactant, if I did the same thing, I've got 1.2 grams of oxygen, O2, I'm going to put that over 1, times 1 mole of oxygen per the formula mass of oxygen, which if I add that up from the periodic table, it's 32 grams, times my mole ratio. Remember, that's a mole over a mole. We need to get rid of the O2. We're looking for water. And if I look at those coefficients from the original balanced reaction between water and oxygen, it's a 6 to 7 ratio. I do that, I solve, and I wind up with 0.032 moles. And that's what you get from the oxygen. The oxygen gave you that many moles of, and that's moles of water. If you remember from what we did with the other reactant, the C2H6, it gave us a value of 0.32 moles of water. Well, to answer the overall question, which do you need more of to produce as much water as possible? It is the smaller of the two values. It is the O2, which is the reactant that limits the reaction. It is the O2, which you need more of to produce as much water as possible. And that's how you do one of these problems. I'm going to caution you, I'm going to warn you that when you do these problems on our AAA, you absolutely need to show your dimensional analysis. That is one of the two learning targets we're assessing. So when you do that, you want to show all of this work. Don't forget your units. All of your units need to be there, which includes not just like grams, but actually grams and the chemical you are talking about, moles and the chemical you're talking about. So you've got to include all of those units. Otherwise, the best you're going to get for that learning target score is a 2 out of 4. You are not demonstrating that you can do dimensional analysis correctly. So make sure that you do that, you show your work, you get the correct answer. If you do that, you're going to get the right answer every time and be in good shape. I hope this video helped, and good luck studying. I will see you in class for that AAA.